In the vast stretches of space, where time feels suspended and the light from distant stars travels for hundreds of years before reaching our eyes, there lies a celestial titan, Betelgeuse. This red supergiant, glowing ominously in the shoulder of the Orion constellation, has been a subject of wonder, speculation, and mystery for centuries. But what if we told you that something is happening to Betelgeuse, something strange, something that could, in cosmic terms, happen any moment now? Betelgeuse isn't just any star. It's one of the largest stars visible to the naked eye, so massive that if it replaced the Sun in our solar system, its surface would extend beyond the orbit of Jupiter. But what truly makes Betelgeuse a subject of intense interest among astronomers is the fact that it's dying. And when a star like Betelgeuse dies, it doesn't go quietly into the night. It explodes, in a violent, dazzling display known as a supernova. For years, scientists have been watching Betelgeuse carefully, looking for signs that it may be nearing the end of its life. In late 2019 and early 2020, Betelgeuse dimmed dramatically. To the naked eye, it appeared as if the star was fading away. This unexpected dimming sparked a wave of speculation around the globe. Was this the beginning of the end? Was Betelgeuse preparing to go supernova? Though the star eventually returned to its normal brightness, the dimming event left scientists puzzled. Research suggested that a massive cloud of dust ejected from the star might have caused the darkening. Betelgeuse, in its old age, is unstable. It pulses and throws off layers of its outer atmosphere into space. When one of these layers cooled down and condensed into dust, it briefly obscured the light we receive from the star. But even this explanation didn't fully resolve the mystery. It only made things more interesting. More recently, data collected by NASA's Hubble Space Telescope and other ground-based observatories has revealed something even more startling. Betelgeuse isn't just unstable. It may have already undergone a massive surface eruption, a rare event called a surface mass ejection, or SME. Unlike a solar flare from our Sun, which is already a powerful phenomenon, this eruption from Betelgeuse was several 100 billion times more energetic. It blew off a colossal portion of the star's surface into space. Imagine a wave of plasma and gas, so massive it could engulf our entire solar system, being hurled into the darkness at incredible speed. That's the kind of scale we're talking about. To put this into perspective, the eruption from Betelgeuse was so violent it may have permanently altered the star's internal structure. The photosphere, the visible surface of the star, was literally torn apart. The star is now slowly recovering, trying to stabilize after such a cataclysmic event. But this recovery process has left a signature: fluctuations in brightness, irregular pulses, and a sense of growing instability. These signs are important because they could indicate that Betelgeuse is nearing the end of its life cycle. Supernovae don't occur randomly. They follow a sequence of stages inside the star. In its core, Betelgeuse has likely already burned through its hydrogen, helium, carbon, and maybe even oxygen. If it has started fusing heavier elements like silicon, then it's not long before it reaches iron, a point of no return. Iron fusion doesn't produce energy. It consumes it. When the star's core is made almost entirely of iron, gravity wins. The core collapses, and in the blink of an eye, a supernova is born. But what happens when Betelgeuse does explode? If Betelgeuse goes supernova, it will be a once-in-a-lifetime event for humanity. From Earth, the explosion will be visible even during the day. For weeks or even months, it may shine as brightly as the full moon. The night sky will be forever changed. And while it might sound terrifying, we don't need to worry about being in danger. Betelgeuse is about 642 light-years away, far enough that its death won't harm us, but close enough that we'll get a front-row seat to one of the most awe-inspiring events in the universe. There's also the question of what will be left behind. When a massive star like Betelgeuse explodes, its core collapses into either a neutron star or a black hole, depending on the final mass. A neutron star is an ultra-dense object, just a few kilometers wide but with a mass greater than our Sun. It spins rapidly, emitting beams of radiation from its poles. If we're lucky and the beams point toward Earth, we might detect it as a pulsar. On the other hand, if Betelgeuse is massive enough, it could collapse into a black hole, a region of space so dense that nothing, not even light, can escape its gravitational pull. This potential transformation has stirred excitement among scientists. Instruments like the James Webb Space Telescope and ground-based detectors like the Very Large Telescope, VLT, are all poised, watching and waiting. They want to capture the explosion in as much detail as possible. Studying a nearby supernova would allow researchers to test their models of stellar death and refine our understanding of the life cycles of stars. It would be like having a cosmic laboratory unfold right in our celestial backyard. But there's still so much we don't know. The timeline remains uncertain. In astronomical terms, soon could mean tomorrow, or it could mean in 100,000 years. Betelgeuse's life hangs in cosmic suspense, and we are the audience. The signals of its final act might already be on their way to Earth, traveling through space at the speed of light. One day, we might wake up and see a new light in the sky, blazing where Betelgeuse once stood. And when that day comes, the universe will have written a new chapter in its grand story. What adds an eerie layer to this narrative is the possibility that the explosion has already occurred, and we just don't know it yet. Because Betelgeuse is 642 light-years away, the light from its supernova will take 642 years to reach Earth. If it exploded today, we wouldn't see it until the year 2667. But if it exploded back in the 14th century, say during the time of the Black Plague in Europe, that light would be arriving now. Imagine the chilling irony, that one of the brightest cosmic events in history is unfolding at this very moment, invisible to us only because of the vast cosmic distance. For ancient civilizations, Betelgeuse was more than just a star. The Maya, the Greeks, and the Arabs all recorded it in myth and legend. Its blood-red hue gave it an aura of warning, of power, of something divine or dangerous. Perhaps they too sensed its uniqueness. Today, armed with telescopes and algorithms, we understand it better than they did. But the awe remains the same. Now, with modern technology, we can monitor every flicker, every pulse, every eruption. Artificial intelligence systems are being trained to analyze light curves from Betelgeuse in real time, searching for anomalies that might signal an impending collapse. Astronomers have placed the star under near-constant surveillance. Observatories around the globe coordinate to track its behavior, and data is shared across continents in real time. It's like we're watching a ticking time bomb with no countdown. Some scientists are even looking at neutrino detectors to catch the first whispers of Betelgeuse's death. Neutrinos are ghostly particles that can pass through matter undisturbed. When a star goes supernova, it releases a flood of neutrinos before the light even arrives. If detectors on Earth suddenly register an unexpected neutrino burst from the Orion direction, we may only have hours before the light of the explosion reaches us. That would be our first warning, and one that would send observatories into a frenzy of activity. What's both terrifying and beautiful is the sheer inevitability of it all. Betelgeuse will go supernova. It's not a question of if, but when. And when it does, we will witness something that hasn't happened this close to Earth in modern history. The last nearby supernova visible to the naked eye occurred in 1604 and was documented by Johannes Kepler. But Betelgeuse is even closer, and far more dramatic. As we look up into the night sky and see that reddish glow marking Orion's shoulder, it's sobering to realize that we're staring at a dying star. A celestial giant in its final breaths. And yet, there's something poetic in that. Stars are the engines of creation. Their deaths seed the cosmos with heavy elements, carbon, oxygen, iron, everything needed for planets, life, and even our own bodies. We are, quite literally, made of star stuff. So, in a way, Betelgeuse's death is not an end, but a beginning. A transformation. A cosmic rebirth. And maybe, just maybe, one quiet night, you'll step outside and notice something new in the sky. A strange light where Betelgeuse once twinkled. A light that defies the stars around it. You'll look up and realize you are witnessing history, not just of mankind, but of the universe itself. A light that began its journey centuries ago will finally touch Earth, telling us the story of a great star's final blaze of glory. So we wait. We observe. We wonder. And as Betelgeuse pulses and trembles, it reminds us that the universe is alive, always changing, always unfolding its secrets. And one day soon, those secrets may shine brighter than ever before.